Ladies and gentlemen, Kodotako here, and welcome back to another video. So this video is a tutorial about Lua metatables in Roblox. So let's get started, okay? So as you know, Lua metatables are really complicated subjects for a lot of Lua developers because it's really advanced. In fact, it's not that hard though, but it's really hard to explain, which means that it's really hard to learn also. But once you get like you understand what's going on about it, it's really simple actually. But yeah. So the thing is, as you know, that Lua have only one data structure, which is a table. It doesn't have OOP or object-oriented programming natively. It doesn't know anything about that. So just using tables, which are like dictionaries in Python, and or if you want the technical word, it's a hash table. And metaprogramming, you can do whatever data structure you like to, which is really awesome and beautiful. But yeah, so let's make a script, and I'm gonna create a module script. All right, so let's say I want to create a module that is called vec2, which means it's gonna be a vector2, mathematical vector2. Okay, let's go. So local, it's of course it's going to be a object basically. So local vec2 equal to a table, and I'm going to return vec2. Nice stuff. All right. Now I'm going to say vec2 dot two underscores index equal to vec2, just like that. And whatever property that is inside the table that starts with two underscores, it's called a meta method, or at least it's reserved as a meta method. So yeah, so two double underscores, right? Index is a meta method. Cool. Now we need a function called new vec2.new. I mean, you can call it whatever you want, but this is the standard basically. And so yeah, this is the function. This is a static function if you're coming from Java or whatever. This is a static function that will actually make for us a new vector2 instance from the vec2 class. So basically this table right here, vec2, will work as the actual meta table or the class. And we're basically gonna create new instances from that class. So local new instance basically, or let's say instance, for example, equal to a new table. And we're gonna return set metatable, the object that you want, which is instance, and the class, which is in this case vec2. All right, cool stuff. Great. Now, the thing is, when you are in a script, let's require this module, local vec2 equal to require script.vec2, just like that, cool stuff. And now we're just gonna create a new vec. Let's call it a, for example, equal to vec2.new. And pretty much we have just made a new vector2 object or instance. Now I can just print a if you want to, and we can just run it. And there we go. But our table is nothing and it's doing nothing, and it's obviously not a vector2, at least not a usable one. So the thing is that you expect from a vector2 class is that you can actually pass to the constructor two values, for example, which is, let's say, the x-axis and the y-axis value, just like that. So that's what I'm going to add right here. So x comma y to the constructor, and then inside the instance I'm going to say x equal to x comma y equal to y. This is the same as Java, but just to make sure this is not confusing for you, I'm just gonna call the parameters, I'm gonna prefix them with p underscore just to make sure you're not confused right there. But the other way around also works actually, and that's what I usually do. But yeah, so as you can see, instance, it's a table, x equal to the parameter x that we got from the constructor, and the parameter y, or the property y, equal to py, or the parameter y, cool stuff. Or you can also say, instead of this, you can say instance dot x equal to p x and instance dot y equal to py. But the other way around is faster and much nicer at the same time. So yeah. All right, now let's run again and let's see what's happening. And as you can see, right now we got our object with x equal to 10, y equal to 20, which is really nice. It's a good new start. Cool. Now, the thing is, let's create another instance of the vec2 class, b equal to vec2.new. Let's say 20, 10. All right. And then I'm just going to print both, print a and print b. Now let's see. All right, so as you can see, this is a, x equal 10, y equal to 20, and this is b, x equal to 20 and y equal to 10, which is quite nice. Cool. All right, now, the thing is, as a vector class, you want to be able to add new vector, like two vectors together. So this is what we're gonna do. We're gonna add, if you can see here that this is a dot, not a colon, which means that it's a static method, as a convention at least. But I'm gonna show you later why it's just as a convention. But yeah, so vec2, I'm gonna add a new member method, which is called add. All right, and this method will work on the current instance that is run on, and you will need another other vec2 basically, which I'm just gonna call other though. Cool. Now we're gonna return a new vector2, so return vec2.new. We're not gonna modify the current vector or the other vector. We're just gonna return a new vector without modifying the other ones. But yeah, vec2.new, we're gonna say self. So the thing is, whenever you use the colon, what happens is that you have a new parameter called self, which refers to the object that you used it on. So for example, if I say vec, or let's say if I say a colon add, just like that, b. So what's gonna happen? This is the same as a dot add a comma b, basically. So what happens is that this object right here goes on to the first parameter, and it's called self, basically. I'm not sure if that's like you understood it or not, but basically this is the same as this, but this is a syntactic sugar to make it much cleaner, much nicer, just like OOP. I'm gonna show you how it will work, but yeah, just a heads up right there. So vec2.new self.x plus other.x comma self.y plus other.y. This is how you add two vec2s in mathematics or linear algebra, whatever you want. But yeah, so as you can see, vec2.new, we're returning a new vector2 with the parameter self.x plus other.x comma the y is self.y plus other.y. And just to make it much nicer, I'm gonna put everything in its own variable. Local x equal to that, and local y equal to that. And just to make it much cleaner, I'm just gonna say new x, new y, just to make sure my code is understandable. Just like that. Cool. As you can see, I'm calculating the new x and I'm calculating the new y from self and from other, and I'm just returning new variables. So let's try that out. So local c equal to a add b, just like that. Cool. As you can see, A, the first object, the first vec2 object, colon, add the second or the other vec2 object B, just like that. Cool. Now I'm just gonna print C. I'm gonna see what's gonna happen right there. All right, so right now I'm printing C, and as you can see, it gave me 30 in the X and the Y. Why? Because 10 plus 20 is equal to 30, and 20 plus 10 is equal to 30. And of course, it returned for me a new vec2. It constructed a new vec2 from those vec2s. It didn't modify any one of them. Well, in your own module, you can modify one of them if you want to, but usually that's not really the case that you want, but yeah, whatever. All right, cool stuff. Let's also add another vector, or another operation, should I say. Vec2 sub, and I'm just gonna change these signs right here to minus instead of plus, and it should be good to go. Now, if I go ahead and instead of add, I'm gonna say sub, and let's see what's gonna happen here. Run, and this is what we got. For the first one, we got minus 10, and for the second one, we got 10. So basically 10 minus 20, we got minus 10, and 20 minus 10, we got 10. Cool stuff, isn't it? And of course, if you change the order of this, guys, then, well, the results will also change. 10 minus 10, because in the subtraction operation, order matters. So yeah, that's cool and all, but hey, wait a sec. Whenever I print a new print a vec2, I get this ugly syntax like this as a table. But the thing is, I want it to be something much cleaner, much beautiful, much nicer than just that ugly syntax right there. So how I can do that? Well, I need to use another meta method, which is called toString. So how I can do it? Let's see. So function colon toString. Oh wait, what I'm doing? Function vec2 two underscores toString. This is a meta method called toString. And it should be like this, exactly like this. So yeah. All right, now if we just return self.x, or actually let's go with a string, okay? I'm gonna say d %d, comma, %d, I'm gonna wrap them in a parentheses, and I'm gonna use string.format on that. I'm gonna give it two parameters after that, self.x and self.y. Just like this. Let's see what's the result of this. Run. And boom. Now, whenever you try to print a vec2 instance, this is what you get. Like two parentheses, 10 minus 10, the x and the y basically. Look at that, so beautiful. I mean, you can do it in another way. I use string.format, which is much cleaner, but if you're a beginner, you can also do this. So return x, self.x, and of course this should be, you should use toString here because self.x is a number, not a string. And then I can use the concatenation operator for strings, and I can concatenate it with comma, just like this, and I can concatenate again toString self.y, and again I can concatenate a parentheses, another parentheses right there, just like that. Cool. And this would work too. And if we actually run this up, you can see that it's exactly the same, but this is much, much cleaner. Now, after I've shown you the primitive way to do it, let me show you how this works. So return string.format. So there is a method inside the standard library string called format, which you can give it a string as a format string, right? As you can see, there is some parentheses right here, and there is this percent operators. So when you do percent D means that we're gonna substitute this with another number, basically. So basically we're gonna substitute these two places with two numbers. So this first one will be substituted by the first argument of the variadic function or variadic arguments, and self.y will be substituted here, basically, which is quite nice. If you say f, then instead of a digit or just a simple number, it's going to be a float, which means it's going to have a comma right here. And that is actually needed. Why? Because, well, let's use D right now, and let's actually add some comma stuff right here and right here, just like that, okay? Now let's run this up and let's see what happens. Well, we know that this will give a result with a comma, but as you can see, it didn't work right here. It didn't show the comma because, well, we told it to format it as a integer, as just a whole number. So what we should do is we should use f, which is a floating number, which means you just have a comma, basically. And as you can see, right now it works, but, well, it gives this big number, and if you want to make it much nicer, you can limit the precision after the comma of the representation, not the calculation. So we can say before the f, 0.2, for example, 0.2. All right, let's see. So as you can see right now, it only prints until 2 decimal places. And if I say 3, it will do the same thing, but with 3 decimal places. If I say 1, the same thing again, but with 1 decimal place, as you can see. That doesn't change the actual x and y value, it just changes the way you represent it to the user, how you format it to the user, basically. But that's just about it. All right, so we got add, we got sub, and we should of course have a mul method or multiply. And of course, I'm just gonna change the signs, right? The operators, just like that, so simple. And div, just like that. He would ideally do this operations in one line, but just to make sure it's much cleaner and readable, I just did it this way. But yeah, now we can also use, let's say b div a, which is basically divided by. And as you can see, it worked perfectly because 20.5 divided by 10.5, it gives us 0.5. But yeah, does that makes, actually no, we divide 10.5 by 20.5. All right, because b divided by a, basically. But yeah. Now, the thing is, usually you don't want it to do it like this. You want to do something like this, right? But if we do something like this, then we get an error. Attempt to perform arithmetic dev on table. All right. So how we can allow such thing? Because as you can see, if you used operators, then, well, it no longer works as you expect to. It just says attempt to perform arithmetic, in parentheses, the operator on table. Why? Because the table or the class vic2 doesn't have a meta method called add or whatever. So let's say vic2 colon, and let's say 2 underscores add, just like that. And of course, you're gonna get the other, just like that. Cool. And now we're just gonna return a new vector2 once again. Or actually, I'm just gonna say return self add other, just like that. I basically just used this, I redirected it to this method that I already made, which is quite nice. So now if I run this up, You can see that it worked. So right now, this works. So b plus a, it gives us the right value. A plus b, of course, it does too. And there we go. Nice stuff. Love it. And if we say a minus b, well, run. Well, that doesn't work because we haven't made the meta method for it yet. So I'm just going to copy that. I'm going to say sub, just like that. And I'm just going to, yeah, that's basically it, actually. Let's run that up. And there we go, minus 9.7. 10.0 because 20.5 minus 10.5, it gives us 10.0, which is perfect. Now, if we change the order minus our b minus a, should, yeah, actually it changed the sign, which is nice. Cool. Now, what if we do something like minus a? Would that run? Well, of course not, because we need another method to do that, basically, which is called unm. So let's do that function. Or actually, I'm just gonna paste the stuff right there. I'm gonna say unm. And here I'm just gonna call that method unm just like that, I believe. And there's no other in this case because this is not a binary operator. This is a single unary operator because there is no other thing. For example, in a plus b, there is two elements. There is b and there's a. But in minus a, there is one element. So it's a unary operator, not a binary operator. But yeah, so of course I still don't have this function called unm. So this is what I'm gonna do right here. I'm gonna add it. So function vic2 unm, just like that. We're gonna return a new vector2 once again. So vec2.new. All right, and I'm just gonna say minus, or actually, you know what? Let's just copy this stuff just to make it cleaner. And I don't need the other stuff. Cool. And I'm just gonna say minus self.x minus self.y. That's what it is. New x, new y. All right, cool stuff. Now let's run this up, and there we go. As you can see, C, which we printed here, is the reverse of A. So basically reverse the signs, which is quite nice. Lovely. All right, so as you can see, we have defined the unm, the add, the sub. Let's go ahead and also add other ones like multiply and divide. Mul, div, just like that. Cool. And we're just gonna go self mul and self div. That should work too right now. That should allows us to also say a times b or a divided by b just fine. And looks like it's perfect. Cool. We can also add some new constructors. We can say function vic2 dot 0, and it's just gonna return a new vector2. So vic2 dot new 0, 0, basically. And we can also add another one like vic2 dot 1, you know, and we can say 1, 1, just like that. Cool stuff. And now we can also do something like a times vic2 dot 0. So this basically will construct a new vector that have x equal to 0 and y equal to 0, which means we're going to get 0, 0, 0 because, well, anything multiplied by 0 will give you a 0. And if we divide, we're going to have a problem, which is going to give us an infinity kind of thing. But yeah. All right, we can also add some condition into the divide function. So let's say we don't want to allow our coder to divide, let's say, vectors on some zero. Like, you don't want people to divide by zero. You want to throw error when that happens, because actually this kind of thing where you actually divide by zero creates a lot of problems, since it actually doesn't error or something. It just returns for you infinity, which might be the thing that you want or might not be the thing that you want, and can create a lot of like nasty bugs. But let's say in your own module you want to make sure that errors. So here's how we can do it. So we can say if other dot x equal to 0, then or other dot y equal to 0, then we can error. And the message, let's say, cannot divide vec2 by 0. Or let's just say cannot divide by 0. Just like that. And we can say vec2 right here or something. But yeah. All right, let's try that up. And if we run this, and as you can see, it thrown an error. vec2 cannot divide by 0. But what if I divided by 1, vec2.1, just like that? As you can see, it works just fine. And anything divided by 1, it remains the same. So that's what happened there. Quite nice. So yeah, if you want that too, well, you can do it. So basically in your own module, you can do whatever you want, whatever like behavior you can think of. And I still didn't really explain this index method. So it's kind of hard to explain actually. But let me first print the class vec2, because until now we only printed the instances, not the class vec2. All right, so this is what the class have. It have an add method, a div, mul, sub, u, and m. You have this methods, add, div, index, mul, sub, toString. And for index, it told us that it's a cycle table reference detected, because basically it references itself. And so if it gone ahead and it printed itself once again, it's gonna keep on going like that and printing itself forever, recursively, basically. All right. There's the toString meta method. There's the u and m. There's the new 1, 0, etc., etc. So as you can see, this vec2 table have the meta methods index. It have the member functions. It have the static methods, which are the constructors, right? Which is quite nice. So that's why in the constructor, where is it? There we go. So we're creating a new table, a new regular table, just like you would. And we're setting x to px and y to py. And after that, we're returning set metatable instance vec2. And by the way, we can do the same like this. We can just set the metatable, and then we can just return the instance. This is the same as this, but this is much cleaner, basically. But the thing is, what this does, it just sets the metatable of this table into this table. So any table can actually behave as a metatable to another table. It's just that you use the set metatable function. And of course, after this function actually sets the metatable of the instance to this vec2, it just returns the table that you gave it, which is quite nice here. Cool. So yeah, that's just basically how it works. And because vec2 have some meta methods, so which means that those meta methods will actually apply on this table. So yeah, I hope that's a bit understandable. It's really hard to explain, but when you get to understand, it's really easy, really simple. But yeah, so what else we can do? Well, let's check the wiki, new private window. And we're gonna say Roblox metatables or meta methods. And of course, there is a whole wiki page for the meta tables of Roblox. And there is a lot of stuff. There is index, there is new index. And as you can see, there is table. And by the way, let me show you the thing that I wanted to show you before. So as you know, I can do something like this, A add B, right? And if I run this up, it's going to give me the results quite nicely. Cool. Now the thing is, I can do it the same way using point instead of colon, but I have to say A once again. So basically, what you have to remember that this is equal to this. Just like that. It basically passes itself automatically after the first parameter, and that parameter, it passes to you as self. So basically, you can only use this self if you are actually using the colon. Otherwise, let's say you only allow to use the point in the implementation. And so after that, you have to actually declare the self right there. So this is the same as this. The exact same, because that colon thing is just a syntactic sugar. That's basically it. Just a nicer way to do it, basically. But yeah, I think you got the point. And that's why in the meta tables right here, if you can see, for example, toString, where is toString? There we go. It takes one parameter, which is a table. So for me, normally you would do something like this: point toString, and then you say table or self, and then you just use it after that. But for me, I just made it much nicer and just said colon, and I just used self directly. So that's just basically how it goes. All right. So as you can see, for example, toString, it gives you back a table, which is basically the instance. Fired when toString is called on the table. There's also the POW meta method. There's the modulus that we missed actually. So let's add those, because why not? I mean, it's real simple to do. Div unm function. Actually, let's just go like this. And I'm gonna call it POW. You can, by the way, call your functions whichever you want, doesn't matter. The only thing that you should call exactly how it is the meta methods, right? Because that's how the function knows what kind of behavior that you're describing. It should be the same as it is. But for the other stuff, doesn't matter the name. So yeah. So POW, how we can do it? Well, of course, there is the other parameter, just like that. We're gonna say self.x times actually POW or power off self or other.x. Power off other.y. You can also use the math method, just like this. Math.pow self.x, comma other.x instead of that operator. But yeah, you can use whatever you want. Run. And well, we still didn't use that pow method, so let's do that. So A, power off B. Run. And well, attempt to perform arithmetic. Oh, well, I mean, I created the method so I can do something like this, but I still didn't create the actual method to do it. As you can see, it gives me this large vector, but yeah. So let's do that. Let's add the method too. So I'm just gonna copy, let's say div, and I'm just gonna call it pow, and I'm just gonna use my new function pow. I mean, by the way, you don't have to actually add these methods. You can just go ahead and directly add the behavior that you want inside of here, like inside of the meta table or meta method function implementations. but it's just nicer if someone wants to also use your wants to use your module just like this way, just using functions, because in fact, the meta methods way right here is it's called operator overloading. But let's say, for example, in C, there is no operator overloading, which means you have to work with your modules like this. So there's might be some people who actually like is much more nicer for them to use actual functions instead of just operators, um, for any kind of reason. But yeah, you got the point. So in this case, we're giving both features. You can use it as a function or as an operator, doesn't matter. But yeah, so now let's add another method, which is the last operator in Lua, which is called mod or modulo. And modulo, basically we're gonna do the same thing. We're just gonna change the operator. That's it. We're gonna add the meta method. We're gonna call it mod and the mod function like this. And if you notice that when you don't have a meta, like when you try to use an operator that isn't implemented as a meta method, it gives you an error, and it also tells you the kind of meta method that is. So let me, by the way, comment this, and let me show you. So basically this is not, it doesn't exist. And let's try to use a modulo b. And let's run. It's going to give me an error. As you can see, attempt to perform arithmetic. And it tells you what is the meta method, which is mod in this case, on table, which is quite nice. All right, now I can just go ahead and I can say this. Cool. And there we go. All right, now let's try it again. Since, yeah, there we go. 10.5, 10.0. Quite nice stuff. All right. So as you can see, we have just made that up. And by the way, if you use the native vector2 .new object, let's see if it's actually able to overload this operator. If not, then we win here. Yeah. Let's say 1, 2, 2, 1, for example. Let's run. As you can see, attempt to perform arithmetic mod on vector2. And of course, you can't actually set the metatable of vector2 because it's locked. I mean, just try to do that basically. Let's see what we can do. A plus b here. Let me try to do something. For example, let's try to set the metatable of vec2 or vector2 to vec2 basically. Actually, let's not do it here. Let's do it somewhere else. For example, the script. Let's see what's going to happen right there. There we go. Attempt to modify a read-only table. Because vector2 is actually a metatable, like an object that is given by Roblox, and it's also used in metatables, but its metatable is locked. You can't actually modify it, as you can see here. And in fact, you can do the same thing, because in fact, if you go ahead and you say set metatable a to nothing, to nil. In fact, let me do it after declaring a, my bad. Let's go, and let's see what's gonna happen if I print a. So as you can see, it gave me back the table as it is. Let me not print this up just to make sure. So I'm gonna do this two things. I'm gonna print a before, like when it had its own meta table. And after that, I'm gonna delete the metatable of a. I'm gonna set it to nil basically. And I'm gonna print a once again. And let's see. And there we go. So this is a with the metatable, and this is printing a without the metatable. Looking cool, huh? But now let's say we don't want to allow that. How we can do it? Well, there is a meta method for that. I don't use it that much though, but as you can see, if present, there's a meta method called metatable. If present, lock the metatable, so get metatable will return this instead of the metatable, and set metatable will error. All right, let's try that up. So I'm gonna add it to my vic2 here. So vic2 dot metatable equal to, let's say, um, hmm, let's set it to a hello there, hello world. Let's set it to that, and let's see what's gonna happen here. And there we go. Cannot change a protected metatable, as you can see here. So when I tried to set the metatable again of A, it didn't allow me to do that because the metatable meta method is actually present. Well, in this case, I just set it to a string, but you can set it to whatever you want, looks like. Doesn't really matter. As long as it's not nil, it will actually lock it, and no one can actually set the metatable for you, which is quite nice. And well, there is another thing that we can cover, which is the comparison operators. For example, equal equal. There is greater than, there is less than, there is less than or equal to. That's a lot to cover, but let's actually start at least. I'm gonna cover at least this equal equal operator, because right now, well, if you print A equal to B, then what happens is that it's gonna tell you, well, wait, what? How? Oh yeah. All right, gotcha. All right. So let's say I print vic2 dot 0 equal to vic2 dot 0. Well, as a human, it's logical that these are the same vectors. Why? Because they have the same components, the same x and the same y value. Let's try that out. Run. And as you can see, it says false. Why? Because right here, it's not actually doing what we think it should. It's doing the default behavior of Lua equal operator, which is, or actually comparison equal operator, but yeah, which is to just compare the reference of the table. So is it the same table or not? Not if it's the same components or the same values or whatever. So how we can override this default behavior is by adding a new metatable called EQ. So let's do that once again, and we can add a function for it, why not? Vec2 EQ, just like that. I'm gonna say other, actually, yeah, other, exactly. And I'm just gonna say return, well, self dot x equal to other dot x and self dot y equal to other dot y, just like that. So basically, instead of letting it be as the default, now actually, let's just go ahead and let's try it out. So I'm gonna use the function because we didn't make the metatable yet. So EQ that, and let's see if that works out or not. And there we go. As you can see, true, which means it's nice, cool. Now, the thing is, let's add a new metatable for that too. So we can actually do something like this with our own behavior instead of the default behavior. So let's do that. Function vic2 EQ other vic2, right? vic2 EQ other return, and it's so sweaty right here. It's so hot, and I've been like talking for a while, but yeah. So self return self EQ other, just like that. Cool. Now let's run this up. And by the way, we're going to find this script code in the description, probably in GitHub, but yeah. So as you can see, it told me true, which is quite nice. All right, so that's equal. What else? So as you can see, for example, this one, it's the less than operator. The LE is the greater than operator and stuff like that. For example, this method GC, it's disabled in Roblox, so you can't use it. And len is also disabled, I believe. Only user data actually respect the len method. As you can see, because of Lua 5.1, only user data actually respect the len meta method. So yeah. There's also the call. There's the new index and there's the index, which are quite important. And the thing is, if you can see here that in the index method, I just set it to itself. But why exactly? And now the thing is, when you set, so first of all, let's talk about what triggers this method, because it's really hard to explain actually. But the thing is, all right, let us see. I'm gonna actually explain using regular tables. Okay, let's say I have a regular table like this, all right? And then I just say print t.a, all right? So of course the property a doesn't exist inside the table t because table t is empty. So let's run this up, and as you can see, it gives me nil. Now the thing is, before it actually gave me nil, it first of all looked for if the table does have a meta table. Well, in this case, it didn't have a meta table. So well, it just phoned back to the default behavior, which is just to give back nil. All right, cool. Now let's actually have another meta table. Let's say we have a meta table, for example. It's just an empty table, a regular table, right? And then we're just going to say set meta table t to meta table. Just like that, okay? And then I'm going to print t.a. Let's see what's going to happen right there. Again, it's the same thing now. Why? Because yes, there is a meta table, but there isn't any kind of meta methods or whatever. So how we can go through that? How we can actually do that, basically, we can use the index meta method. So the index meta method fires when table index is indexed. If table index is nil, can also be set to a table, in which case that table will be indexed. That's the the baddest description I've ever read, but yeah, I'll try to describe it as much as possible. So inside the meta table, I'm gonna have something called index. It's gonna be equal to a new function. All right. So this function would take a table and an index. All right. Cool. Now, let me print table and let me print index. So I just can show you what happens right there. And in this case, I'm just gonna return nil for now. And let's run this and let's see what's gonna happen. And well, as you can see here, is that it actually prints the table. It printed the index, which is in this case a. And of course, it printed nil. Now, let me change something. Remember this thing right here, and let's see what's gonna change. So let's say instead of return nil, I'm gonna say return 10, for example. Or let's say return 0 instead of nil. Let's run this up. And as you can see, it actually returns 0. So whenever, right now, you try to access a property that doesn't exist in the table T with the metatable that has a meta method called index with this following code, it's going to return for you 0 instead of nil. And that's the case. And we can also do something else other than this, which is error. We can just error. And you can say the property. I'm going to use string.format. All right, so the property percent %s, which is basically a placeholder for a string. So the property is doesn't exist in the table, just like that. All right. And after that, I'm going to give it the placeholder for that string, which is basically the index. And now let's see what's going to happen though. Run. And as you can see, the property A doesn't exist in the table. So for the Lua haters that basically doesn't like this behavior of Lua tables, where if it doesn't like, if there's that property doesn't exist, instead of throwing an error, it gives you back a nil. Well, you can do whatever you want with metatables. And also for the Lua haters who hates the fact that Lua tables start with the index 1, they can also use meta methods, which I'm not going to show in this video because this video is already too long, because it needs some more clever meta method stuff, but which I can cover later on. If you want me to do so, let me know in the comments. But basically, you can do you can customize Lua tables however you want. You can even make something like Python's behavior of lists. But yeah, I think you got the point right here. So as you can see right here, so the thing is that you should know or understand is that the index meta method triggers when the property that we're trying to access doesn't exist in the table. So let's say if A exists, A equal to, for example, a number. So basically right now A exists. So it didn't trigger that index meta method. But when A doesn't exist, then it actually triggers that. Let's say print t dot hello. And as you can see, both of them will trigger the index meta method, as you can see here. But that one already gave us error. So as you can see, the property hello doesn't exist in the table. Cool stuff. Now let's do some cooler things. Maybe let's see. Okay, so the thing is, instead of using it like this, instead of giving index as a method like this and just doing whatever you want with the table and the index, what we can do also is instead of giving it a function, we can give it another table. So let's say I have a table, another table called default, and I'm going to say index equal to default, basically. So you can either give index as a table or as a function. So I've shown you the function or method one. Now I'm going to show you the when you make it as a table. All right. So right now, if I say t.hello, what happens is that it's going to give me back nil. All right. But if I say default, so inside of default, I can say hello equal to dude. Let's see. So as you can see, it printed dude, right? Because, yeah, that property hello doesn't exist in the table, but it does exist in the index meta method. So it gave it to me back, which is quite nice, as you can see here. So basically, this table kind of serves like the default fallback to it. But the thing is that you should be aware of is that if hello is already defined in the original table, like hello original, okay, as you can see, it gives me the original because it didn't trigger the index because that property already exists. So I think you know what I mean right here. But if that property again doesn't exist, then it gonna gives you the fallback of the meta method. Cool. So that's basically how it works. And for new index though, new index takes only a. All right, so it gives me table index and value. Fires when table index tries to be set. If table index is nil, can also be set to it. Oh my god. I mean, it's like I'm really advanced in Lua, but I cannot really understand that that description, really. That just sucks. Like, dude, what? Please, Roblox, if you're watching this video, can you let me like edit the wiki of Roblox? Like the wiki will be like really long, just like this video. But yeah, at least people will understand what I'm saying. But yeah, all right. Now let's try the new index method. It took me so long to actually understand this stuff, but once I did understood it, I understood that it's not really hard. But the thing that is hard is to actually explain it in the first place. And if it's hard to explain it, then well, it's hard to learn it at the same time. So like if it's hard to teach it, well, it's hard to explain. Or oh my god. I wanted to say if it's hard to teach, then it's hard to learn. But yes. Anyway, so the new index function takes a table, an index, and a value. If you remember, the index table right there took just the table and index. But right now we're taking three parameters: table, index, and value, which is quite nice. Okay, cool. So now for the new index, what's happening right here is that, well, let's just run this. As you can see, this behavior doesn't really trigger this method, but what triggers it? Well, let's say we say t.pi equal to 3.14, all right? Let's see what's gonna happen. But before that, let's just remove this method temporarily. Let's print t once again. Run. So the default behavior when you're trying to set like a property that doesn't exist, like a new property inside the table, what's going to happen is that it's going to basically set it, like add it to the table, basically. But what you can do is you can actually change that behavior. So let's say this table, whatever number you're trying to push into it, it should be an integer. So basically this table will behave like it can only hold integer values. So how we can do it? Well, first of all, actually, let's do the default behavior, which is that just table index equal to value. This is basically what Lua does in default. But if we run this up, we're going to get a C stack overflow. But don't panic. What happened right here is that, well, when we try to set ourselves inside the method, that index to that value, what happened is that we triggered new index again. And when we triggered it again, we did this again. And we triggered it again. And it happens like that. It keeps on recursion. So it keeps on triggering itself. That what happens, and well, it gave you back a C stack overflow because it couldn't keep on recursion because the stack is limited, all right, for recursion function calls. But yeah, so how we can fix that? Well, that's why there is a function called actually I don't really remember, to be honest. Raw set, right? There's a function called raw set, and so raw set and raw get won't ever trigger the meta methods, all right? It will go ahead and will do it the default Lua behavior just like that, okay? So raw get is a replacement. So let's say if you're inside the index meta method and you're doing some custom logic right there and you want to get a value that doesn't necessarily exist in that table, don't use the normal way you would take a variable or a property. Use raw get instead. You say raw get and you say table, comma, and you give it back and you give it the index, and it will give you the value that is inside that index. Otherwise, it will just give you nil, but it won't ever trigger the method again, which means you won't have a C stack overflow. And in my case, new index, I'm going to use raw set table, comma index, comma value, just like that. So this is the exact normal behavior. And as you can see, that's it basically. But as we said, our table only, let's pretend it can only store integer or whole values. So this is how we can do it. Well, I'm gonna say floor, math.floor, so as to remove the comma from that value that they're trying to set. So as you can see, 3.14, and this is the normal behavior. Now let's try it once again. And well, as you can see, pi equal to 3, because you have gone through the new index. But the thing is that you should also be aware of, if pi already exists, let's say pi equal to whatever, hello world. If pi already exists, then it won't actually triggers that new index. So basically what I'm saying here is that you can't actually detect or trigger a method of a property that already exists and it's just getting modified. So in this example right here, as you can see, it just worked fine without triggering the method, which is crazy. And also there is some properties that you defined like this, instead of using this way of setting it, then it won't trigger them, basically. So yeah, that's just how it works. And by that, I basically explained most of the methods. And LE, LT, I'm gonna leave them for you as a exercise, because it's really as simple as EQ, because they're the exact same thing, you know. And there's the call. This is also really useful though. Let's add it. Why not? So I'm just gonna delete this. Oh, and by the way, you can also say something like this. Instead of raw set, you can say error cannot set a new value to the table. Or let's say cannot add a new property to the table. All right, let's run. And as you can see, cannot add a new property to the table because we tried to add t.pi. We tried to add pi right there, but it cannot do that since we triggered that thing, because pi doesn't exist in the table. And so it triggered that method. Quite nice stuff. All right. You can do all sorts of stuff, and I think you understood what I mean by that. But yeah. Now, what's next is, dude, I'm really sweating so much. God damn. All right, back. I just took a quick break. So let's get back to where we was. So, I'm not sure where we was, but cannot add new property to the table. It's tough. I can actually also show you this behavior in another way, which is that I'm just gonna delete this stuff, right? I'm gonna show you something other than this stuff, okay? So I'm just gonna say, I'm gonna create a new vector, okay? Like Roblox vector, not mine. Vector 3.new, or let's say vector 2.new. You can say 10, 20, basically something like that. And what happens is that if I say vec.z, print vec.z, what's gonna happen then? Let's run this up. Z is not a valid member of vector2, as you can see here. But if we created our own vector, local vec myvec, okay, equal to vec2 dot new, right? Mu, right? Dot new, and let's say, for example, 10, 20, just like that. Cool, cool. Now let's print vec.z. Let's see what's gonna happen. Of course, I'm gonna delete this, or at least I'm gonna comment it so it won't work. So because if it triggers an error, it won't run the other code or my code. As you can see, well, oh, I should use my Vic. There we go. Run. And well, it gave me nil. It didn't give me that cool error, But let's say I want my class to also give that cool error of Roblox, right? I mean, we want to look as cool as Roblox, right? So let's add a new method into our class. Let's go. So vec vec. Let's see what we have. So vec2 dot method new in actually index, right? Because we're trying to access a property that doesn't exist, equal to a function, right? And this function will gives us two things, table and what it's called index, right? But I can do the same thing as this, but much nicer. I can do it, for example, here, right after this. I can say function vec2 index, but usually you want such thing to happen to be like on top, just so it's much cleaner, right? Cool. All right. And of course, you're gonna give me the index that doesn't exist. So here, what I'm gonna do is I'm just gonna say error string.format, just like that. I'm gonna say placeholder s, basically a placeholder for a string, is not a valid member of vec2, right? I'm just gonna comma, and we're gonna say index right there. And now let's watch the magic happens. So this is Roblox thing, right? So I just commented it out. Now let's see mine. As you can see, Z is not a valid member of Vic2, so it worked. The only problem with this though is that if you click on this, it's gonna not go into the actual line that you want, but it's gonna go into here. But there is a way to make it a little nicer, which is that if you do a comma, you can see that the error function have another argument called level, which is a number basically. And of course it's optional. That's why there is a like what's called whatever. Halts thread execution that throws an error. The level of information that should be printed defaults to 1. So the default is 1. Now let's actually look for the function error. Ribla. Yeah, Ribla. Okay, it's inside the Lua globals, I believe. Error. And there we go. So there's a whole line right here. As you can see, it terminates the last protected function called and outputs a message as an error message. If the function contained error is not called in a protected function, then the script which called the function will terminate. The error function itself never returns and acts like a script error. Okay. The level argument specifies how to get the error position. With level 1, the default, the error position is where the error function was called. Level 2 points the error to where the function that called error was called, and so on. So basically the default is 1. That's why it's given us to this place right here. But we don't want to give it this place, but we want to give it this place. So what triggered the error basically? If we go to 2, let's try 2 though. Let's try 2. So it said line 14. And as you can see, it is right. Line 14. But the only problem with this though is that when you click it and it's a bug in Roblox that it's still not fixed, that it actually goes into the original error place. But at least what it's printing, it's actually printing the error line. Because by default, it just tells you the line where the error occurs here. So as you can see, 23. But if I said 2, which is the second level where the error have occurred, basically the function, what triggered that error, or that function's call. So which means it is service.script. the line 14. And as you can see, it works perfectly. Full. And this is another cool information that you should have in your tool belt. But yeah. And since let's just make this X and Y like this. Why not? All right. Cool. Now we can also add another thing, which is that if you can see here, I'm gonna do something else, which is that we're gonna say vec.z equal to 10, for example. And if you go right ahead, and you can see that z cannot be assigned to. But if I do it in my own class, my vec.z equal to 10, well, let's try that out. Well, it didn't error at least. And so let's print my vec, run. And well, because it triggered the, oh damn. So I'm gonna comment this out, the method that does that, so I can see the actual stuff inside. As you can see, XYZ. So we added it successfully, which is probably not something you want, but who knows? Toggle count, I'm just gonna get back with that, all right? So now what you can use to do the same thing as Roblox, let's see the error message. Z cannot be assigned to. So you can do the same thing in our own class. So I'm just gonna add a new method. I'm gonna say new index. And of course, index comma value, just like that. String.format. Z cannot be assigned to. So I'm just gonna say cannot be assigned to. And of course, %s is a placeholder for a string, which I'm gonna give back as index. All right, cool stuff. Now let's just go ahead and let's say run. As you can see, well, wait, hold up. I'm gonna comment this out and let's see what's gonna happen there. As you can see, Z cannot be assigned to. Where? In script 14. There we go. Why? Because we used the level 2. So it actually correctly mentioned the script and line number. Quite nice stuff, isn't it? So yeah, that's just basically how it works. Damn. All right. So I think like we pretty much have done a lot of stuff today. For metatable, we can add it even here if we want to. Metatable equal to true. And by convention, we add a class name equals to the class name, basically. Just so when you do something like print my vic.class name, what's going to happen is that, so this is the instance. And even though class name is not a property of that instance, but it's property of the class, you know, let me delete this stuff. And I don't need this stuff anymore. All right, let's see what's happening here. Oh, class name is not a valid member of vic2. Oh, hold on. We did the big error right here. So we set the index method 2 times, right? We have this and we have this. All right, so basically what happened here is that what you need this for, this is really important, because you need it to, because the class is what actually holds up the the functions, the function names, basically. So what we can do, we can actually do this too inside the function itself. So let's do that. So if vec2 index, so if the class have that property, then return it. As basic as that. So local value equal to that. So If value, then return value, end. Just like that. Otherwise, if it doesn't return, then we're gonna error with that it doesn't exist. Let's run this up, and there we go. We have did both behaviors in one function. This looks like magic probably, but yeah, I think it works. So yeah. But hold on. This way of doing things like vic2 dot index equal to a table vic2. This is much more optimized than this. All right. So if you really don't need this, then just go with this way. You don't need to like go crazy with it and add this crazy custom stuff, because this is much more optimized by Roblox at least, to run much faster. And it also requires much less steps, you know. But you get the point. But now, as you can see, I can say myvec.classname, and there we go, vec2. Cool. As basic as that. So I think I'm gonna end the video here, unless if I see something that I missed. Call. I still didn't cover call, dude. All right, so do you remember when, well, let's say instead of vec2.new, I want to say vec2. So if I did this, then it won't work. Why? Attempt to call a table value. So basically, when you have a table value, just like this one that I have here, you can't just go ahead and say t and call it like a function. No, that's not possible as a default behavior in Lua. That's going to throw an error, right? But if you want to add it, well, you can do that. And how you do that? Well, you need a call method. And here I'm going to do an error. I know it's an error, but I just want to show you something real quick. Function vic2, I'm going to add that method called call, because if I don't do the error first in front of you, you're probably going to miss this information, and you're going to be so frustrated later on because it don't work. But yeah, let's just do it the simple way, like the way that we have always done it. So the call method, right? So what I'm gonna do is just that I'm gonna return vec2.new, and I'm gonna say x comma y, and basically it's gonna give you all. So basically what this three dots means, it's a variadic arguments. So whatever parameters comes after this index will goes into here, right? And I'm gonna pass it directly into here, into the vec2.new. So basically I'm just redirecting it, I believe. Hold on a sec. What do you mean by index? No, it's probably not index. Oh yeah, it's not index. Oh damn. All right. Cool stuff. So right now, if I say run, it still doesn't work. Why? Because too simply is that the method doesn't refer to the class itself, doesn't control the class itself, but it does control the instance. So let's say I already have an instance, for example, local vec equal to vec2.new, whatever, who cares? Whatever it is, okay? Now, instead of vec2, like the class, the actual class, I can use the instance and then call it, all right? That's gonna work out. That's gonna work out, right? But it won't work with the instance. But usually you want the instance to work like that, dude. So what we're gonna do is we need the metatable for the class itself. And that's the thing. So yeah, let's go ahead and do that. So class, I'm not gonna do it here, I guess. Oh god. I'm gonna say local class or vic2 metatable. I'm gonna set it to a table just like that. And so instead of using vic2 inside this call thing, I'm gonna use the vic2 metatable. And of course, I'm gonna set the metatable thing. And by the way, I can just say self. Where is it? There we go. Instead of vic2.new self, because I'm already referring to the class. So that makes total sense. So right now, instead of return vic2, I have to return set metatable vic2, comma, vic2 metatable. Just like that. Cool stuff. And now run it up. And there we go. It should be working right now. So now if I print my vec, as you can see, I used the class as a function, which is a table actually. And as you can see, it works just perfectly. Cool stuff. And well, by the way, I could have done this like x comma y, and then I could have just passed it like this, x comma y, run. But the good thing about this way of doing it is that if you changed, like this code or this function would work on any kind of class, whatever the constructor parameters is. Even if you change your class's parameters, like the constructor parameters, where is it? Dot new, right? Oh my god, where is it? There we go. So even if you change the parameters here, it will work just fine, because you're just redirecting all the parameters to that function or to that constructor. So let's get it back as it was. There we go. So yeah, it is, as you can see here. All right, so well, that was it for this video. If you want a follow-up video, let me know, guys. And well, see you later. It's been like around an hour and a half. And this is the first video that I did camera on. But yeah, well, see you later, guys. Goodbye. And make sure, by the way, to subscribe, like the video, because I really placed a lot of work on this video to make it. But yeah, see you later. Goodbye.